Well, hello friends. Today we're going to do a little bit of networking stuff. And we're going to build something for the browser. And it's going to be a daemon or server program that handles the network requests for us so that we don't have to do them in the browser process. And there are very many benefits to this. And we can, for instance, put all the caching in that place, but it will also allow us to extend networking with protocols by building some kind of a pluggable architecture without having to load plugins into the browser process. So something like IO slaves in KDE, for instance, where you would have like a separate IO slave for different protocols. That's my thinking. So we're just going to start by building a simple HTTP handler server, I guess. And this background here is one of my favorites, by the way. So I guess we'll just start by making a directory for this. We can call this network server, maybe? Does that make sense? Network server, or maybe protocol server. Yeah, protocol server is pretty cool. Okay, and let's make sure that we add it to all of the building business. Where are we? Down here. Protocol server. And likewise, when we build the root file system image, we just want to make sure we install this guy. Protocol server. I'm also starting to think that maybe stuff like a protocol server doesn't really belong in /bin, but maybe some other place. But that's a whole other discussion. And I think we are going to make sure that this starts right on startup. So we'll put it in the system server. We'll just say, we'll run a protocol server here. Okay. And let's see what else we need. Servers, protocol server. Maybe we'll have something like protocol.h. And maybe like HTTP protocol. And maybe we'll have a main file. Maybe we'll have an HTTP protocol.cpp. And maybe we'll grab a make file from someone. Maybe from lookup server, doesn't really matter. Lookup. Okay, so protocol.l. Okay, so I think we have the basics here. Now we're going to have to define an IPC protocol for this. So we're going to need a protocol server.ipc and a protocol client.ipc. And let's see how we put those in the make file. I'm going to have to cheat here and look at what audio server does because I don't remember how we do the code generation business. So we're going to, let's see, we make all the CPP files depend on them. I'm not even sure if that makes sense, but let's say that it does. Then we'll have protocol server endpoint.h depends on protocol server.ipc. And it's generated like that. And we do the same for the client. And we gotta make sure that we throw these away when we clean. Okay. So I think maybe we're good there. Okay, and we're going to need something to inherit from the protocol server side. So hold on. Okay, wait, let's define the protocols first. Protocol, I mean the IPC protocol, not the protocol. So, endpoint protocol server, and we have to give it some unique number, so how about 13, or maybe 4, maybe 9. 9 is a good number today. So, this number here, it's just a magic number that has to be different from the client side, because when we generate the code that creates the IPC messages to send back and forth, then they need to have, the client and server needs to be unique. They need to be unique somehow, and this is just how it works right now. And this allows you to have several different types of IPC clients in the same process without them stepping on each other. Anyway, so let's define some API. So what should you be able to send to the server? Something like maybe start download with a string with the URL, maybe something like that. And this will give you a I32 with a download ID. Okay, and we could also have something like stop download. Okay, and this will tell you a full success. It's pretty good. And this here, by the way, means that it's a synchronous API. So when these are things that the client can send to the server. So the server will respond to these synchronously. So the client does not continue execution until these things respond. Okay. Maybe these are maybe these are the things that we need right now. We could have something also like get supported protocols, something like that. And it will give you back a I don't know. Wait, oh, let's not get carried away. Let's just do this. We can have is supported protocol. String protocol bool supported. Okay. It's a pretty nice little protocol definition there. And let's make one for the protocol client as well. So that would be the endpoint. Wait, why is it so weird? Why is this thing indented differently than this one? I don't get it. Anyway, who cares? Protocol client, you will be 13. I'll come up with something to not have to hard code these at some point, but right now they're hard coded, so let's just deal with it. Protocol client, maybe something like download progress notification. Download progress. Maybe just download progress. I32 download ID. And maybe this will give us the maybe the size and like total size and the downloaded size. How about that? And here these are asynchronous. So this is what they look like. So that just means that nothing follows. And it's generally actually, we really should not have any situation where a server has to send something synchronously to the client in any situation, because we don't want to freeze up the server for any reason. So for that reason, anything that goes in a client endpoint should probably be asynchronous. But the system is not going to stop you from making a synchronous thing, but we really shouldn't. So maybe download finished, I32 download ID, bool success. I so want to type it that way, so maybe I should change the definition at some point to just let you do that, but right now it works like this. Download finished. Okay, that's pretty good. So then we're going to need something to inherit from. I mean, I'll show you what happens when we build all this. Protocols P. So what happens now is that we get these endpoint.h files. And protocol server endpoint. Here are all the different messages generated, and here is the protocol server endpoint class. Now we need to inherit from this thing and then implement these virtuals in the subclass. And that's how we will receive these messages. So we'll call it something like the PS client connection, maybe, or just a protocol client connection. I don't know what I like. Maybe PS client connection is pretty good. Okay, and PS client connection.o. Okay. Now let's cheat and look at the AS client connection in the audio server, and we're just going to copy what he does and then strip it down. So here, instead of audio server, we want protocol server endpoint, and you can call it PS client connection, and it inherits from connection IPC server connection NG. NG is for next generation, because there's still an old IPC server connection that is used by the Windows server, and the Windows server needs to be ported to the new generation connection stuff. But the Windows Server IPC code is huge, so it will take some time to port it over. But here we just say protocol server endpoint. And then we instantiated a server-side connection for this, and it has to inherit from protocol server endpoint. That's how we are able to get those virtuals. Okay, and I think this got nice and slim, and then we just need the virtuals. So I guess it's all of these guys. Okay. This is our PS client connection class. Now we can go and implement this right away. PS client connection. And here we get a local socket and a client ID, right? So we're just going to pass these up to connection NG. What else do we need to pass in? The endpoint. So we need to pass ourselves, because we are the endpoint. Okay. Now this connection object, it knows the type of the endpoint through templating, because this is all in the header file, the whole connection NG implementation. So you can look at how the IPC code generator works if you're interested in this type of stuff, but I'm not going to go into that right now. We're just going to use it to build a new IPC service. Okay, so let's keep going with this. And what else did we have? PS client connection die. And handle. I guess we have all those handles. So let's go and grab them here. These are PS client connection : : Okay, and right now in these functions will be called whenever this message comes in from one of our client connections, basically. So we are expected to respond in certain ways here. So here we'll just stub these out for now. So is supported make protocol server is supported protocol response. We'll say false, or I guess we can do it this way. Message dot protocol equals to HTTP. Okay, so this one actually will work now because we can even do two. Wait, what type is this? It's a string amp, const string amp. Okay, so we could probably do two lowercase. Yeah. Cool. And then for start download, we'll just say make protocol server start download response, and that one has a download ID, right? So for now, it'll just say 0, or maybe something cooler like 1, 2, 3. And in the stop download, make protocol server stop download response. I guess that one was supposed to return the success, right? Yeah. So we'll say false. You failed to stop it. Okay. That's pretty good. Let's go and look at audio server client connection to see what he does in. Right, so here we have a global hash map that manages the set of connections. So I think we're going to use the same trick here, that whenever you instantiate a PS client connection, we're just going to add it to this global hash map, and that's how we'll keep it alive. And then when we get told to die, we'll remove it from that hash map, and then there will be no other references to it, so it will be torn down by virtue of being removed from this. And this will allow us to find existing connections, which will probably come in handy later. Okay, so I guess we're gonna need an okay, let's not get carried away. Let's define what a protocol is now. Protocol public. So what should this thing do? I guess this thing will be able to start a download. So virtual, maybe like a virtual ref footer to download. Start download with a URL as the input. And we'll say that's a pure virtual, so you have to provide this if you want to be a protocol class. Ref footer, and we can have class download. And let's grab URL. Okay. And we're going to need some download costs as well. And I guess we'll have an HTTP download for the protocol-specific version of the download cost. Okay, download. That's good. Now let's go and just sketch out the HTTP protocol. Public protocol. For now, it can just look like that. Virtual ref footer download. I'll put that out of line. This can be final, and obviously we're gonna need more state eventually if we want to do stuff like pass custom headers and do authentication and whatnot. But right now we just have we just do the simple API here. So then let's define the download class. What does it mean to be a download? One thing is that it should probably be reference counted. So we'll inherit from ref counted using the, what the hell was this called? It had some name that I learned the other day. A curiously reoccurring template pattern or something like that. Curiously recurring template pattern. That's this pattern right here. You inherit from something that's a template that has yourself as a template parameter. Very nice pattern. I didn't realize that it had a name. I've been doing it for years because it's such a good trick, but now I know the name of it. So let's see, a download, we'll start with a virtual destructor and a virtual, I guess every download would have a URL. Probably we can make this URL based. I think that makes sense. So say URL, return mURL. And URL, all right, and download class, HTTP download, final public download. All right. And HTTP download, override. Now, what does this thing do? I guess the protocol class, when we call start download, I imagine that it's gonna do, let's see, let's just start working on it. Lib Protocol. And then ref footer to download, HTTP protocol, start download. Right. So here is where we will instantiate. We use the HTTP facilities in libcore. So we have chttp request, and maybe that's all that we need right now. We just need the request class. Yes. Okay, so we'll build a CHTTP request here. Set URL. Does it have any other sets that we need to care about? Set method. CHTTP request method get. All right. auto job is request schedule. This will start the network request by connecting to the server in the URL, and I mean, this will happen asynchronously, so it won't do anything until we get to the event loop and it can start actually interacting with HTTP server. But it will try to connect. It will initiate a connection by calling schedule, and then this job, that's what we're going to put inside of the download object. So return make, or no, not make. Just p download. Create with job. We'll move the job into that object. Okay, and let's look at download. We're going to need a static non-null ref footer to HTTP download. Create with job, and we should only let the HTTP protocol call this. So we'll take a badge, make sure that nobody else can call it. And we'll have to forward declare the protocol. And it will take a CHTTP job. So what type is that exactly? It's a ref footer to a C network job. Non-null ref footer to a C network job. We'll do it that way. Class C network job. I mean, we know that it's a CHTTP job, actually, so we could even require that. Or we can cast it somewhere. And then we can cast that. Create a job, pass the badge, and we'll just star the job, casting it to CHTTP job. I cannot cast it because I have to cast that. Maybe we can cast it like that. All right. We can say if job didn't work out, then we'll return a null pair. So then when we create a HTTP download, protocol server, HTTP download, ref footers, non-null ref footer to download, batched protocol, and a non-null ref footer to a CHTTP job. Return type of out line is different. Really? Oh, right. Create with job. That's okay. I thought that this was virtual, but it's not. Right, create with job. And then here we'll just do return adopt new HTTP download, move job. And then this thing should have a constructor that will look like this. Explicit, that takes a non-null ref footer to CHTTP job. And it's also what we should be storing inside of this thing. All right, cool. Let's go and examine this constructor now. So HTTP download, no ref header to chp job. Mjob. And we are going to have to set up some kind of a callback on this job. So on finish, it's going to be, what did we get in on finish? We get the success state. So in this case, we want to say did finish success, I guess. And then did finish will be a download concept. It's protected so that it's intended for our subclasses to call. Did finish full success. All right. Good. So when the job finishes, whether successful or not, we'll call did finish, and then download can do the rest. We'll also need a constructor for download that creates one of those unique IDs. Because we had download IDs in the IPC protocol, right? So let's make sure that we have those here as well. I32 and id, and I think in download CPP we'll just have an incrementing counter for these. For now we'll just do next id. Id s next id plus plus. It's me. What about rollover? Yeah, we should do something smart if it rolls over so that we don't reuse already in use IDs. Could have a free list or something, but right now, whatever. Not right now. Okay, so download needs a destructor. And it also needs that did finish thing. So this is the part where we want to notify the protocol server client, the PS client connection. So each download should probably know which PS client connection initiated it. So we'll take that as a reference here, and then we will store that in a weak pointer, because if the client disconnects before we finish a download, then, you know, we don't want to have a stale pointer to it. Okay, and PS client connection client. We'll just say client is client make weak putter. And we'll need to include the PS client connection here. Okay, and then finally, now that we have the client, we can say if there is a client. If there is no client, turn. I guess we can log something. Download did finish after the client disconnected. Okay, and otherwise we'll do mclient did finish download with our ID and the success flag. Let's see, it will be, initialization order. Let's put them in that order. So now PS client connection needs to have a download did finish. Did finish download, was it? We'll take a batch of downloads so that nobody else can call it. Okay, and this will be the I guess we could pass ourselves, but we could also... That's kind of nice, actually. Let's just pass ourselves. Did finish download. Oh, the batch, right? Batch. Batch for Cusco. PS client connection. That's gonna have did finish download. Now is the time to send the message to the client. We'll tell him send, or what is it, post message? Post message. Damn it, I forget how post message works. Is it templated? No. Post message. Oh, you just instantiate one right here. Audio. No, not audio. Protocol server. : Oh, but this is a client message. My bad. So it's protocol client. Right. That's what I was getting confused about. Protocol client endpoint. Download finished. Download ID and oh, the success flag. We still need the success flag. Right. Full success. Right, and then here we need okay. That's how we send it to the other guy. And we could also have those progress messages. So we could have something like did progress download. And then we could say in there, we could just say download ID, download, progress. Download, what are we going to have in there? Wait, what were the parameters of this again? Total size, downloaded size, right. It's actually a little bit backwards, or maybe it's not. Total size. Size. So this will just be meaningful if we know it. Downloaded size. So we'll have a protected function here that subclasses can call. I'm going to say did progress. Did progress, I guess. I should pronounce it correctly. Total size and size t, downloaded size. And we'll put those here. Make them 0 by default. Okay. And if somebody calls that one, then we'll have a very similar setup to this. Size t downloaded size. Also abort the download situation, I guess. Although probably this wouldn't be the right place to do that, but we definitely should. So I'll leave that there as a reminder. And then we'll have did progress download, pass a badge, and pass this total size and downloaded size. No member did progress download. Okay, So far so good. What is next? We need some kind of API for calling this thing. So I guess we can make a... I was thinking we could have a library of some type that calls this. Call it Lib Protocol, I guess. It's kind of funny that Lib Protocol doesn't actually implement protocols, but rather talks to the protocol server, which does them for you. But it'll be okay. So let's do Lib Protocol. All right. And we will grab some friendly makefile from libaudio. Okay, so maybe we'll have a protocol client. Maybe that's what we'll call the API. Maybe even client, and then it could be namespaced. That would be kind of cool, actually. So why don't we grab that client connection class from here, from the audio, libaudio, and then we'll tailor that to our needs. Now let's make sure that we build Lib Protocol. And since Lib Protocol will depend on the protocol server being built to know about the endpoints, we'll have to build that first. So we'll just do it that way. All right. So, protocol client, this is the audio server, so we're going to have to change things around a bit. Protocolo. Protocol. Wow, there's so many interesting variations. So this will just be called client, but we'll put it in a namespace. Lib Protocol. How about that? Do we have other namespace lib like that? We have a lib thread. Should we just call it protocol? That's kind of weird. Lib Protocol is pretty cool. Okay. So, just going to simplify this whole thing quite a bit. Protocol client endpoint and protocol server endpoint. So, when you implement the client-side endpoint, then you have to inherit from client connection ng, passing both the client endpoint and the server endpoint types, because that allows the receiving code in the IPC version of the client version of the IPC code can differentiate between incoming messages that are responses to synchronous messages to the server and unprovoked or unsolicited messages from the server to us, and because it needs to try decoding incoming messages using both of these endpoints, basically. Okay, so what are the virtuals going to be here? I already forgot what they were. Protocol client IPC. Right, download progress and download finished. Okay, those were all the virtuals, so now we are no longer abstract. And here, let's just get rid of these for now, maybe, or actually, that's essentially what we want. So we'll say on download finish full success, and I32 downloaded. Size T download, or total size, U64 downloaded size. hey, you'll be able to register those hooks if you want. You can hook them. And then we need APIs to invoke the server requests. So let's see, bool is supported protocol, const string protocol. I mean, that's implied, so let's just say it that way. And then we'll have A32 start download. And bool stop download. Download ID. Cool. And then this becomes name space protocol, Lib Protocol even. I don't know if I love this name, but I also don't know what else to call it right now. So we'll just call it this for now. I guess we'll connect through the PS portal. The portal names, I don't know why, where they come from. When I made the Windows server, I originally called the local socket file WS portal because it was like the portal between the Windows server clients and servers, and I thought that was neat. And then came the audio server portal, and now we're adding the protocol server portal. So I guess this naming scheme continues to grow. The handshake part, right? So that's, I feel like we could probably generate this code, but right now we don't. So there's a greeting message that we need to have because that's how we learn the PID and the client ID of each other. So what does the audio server do for that? It just had this stuff here. Yeah, so we're gonna have to have this in our protocol server as well. Oh yeah, and you can have comments in these. So you can say test if a protocol specific AG HTTP download API. It's adorable. I kind of like this format. Maybe we would write it like this. Actually, it would be looking even better. Isn't it beautiful? Maybe it should be like that. Not the most important thing in the world. Okay, so now we're gonna have to implement our own APIs here. So we had client is supported protocol. And I guess, oh, these are the incoming notification messages. So this would be protocol client download finished and download progress. And here we have like on download finish is what it's called. And we just want to give it the message download ID and the message success. On download progress, message download ID, message total size, and finally message downloaded size. Cool. All right. So how do we implement is supported protocol? This thing will, next time we generate, I guess this thing will start working. Servers, protocol server. Yeah, there we go. A bunch of things that need to be fixed, obviously. So this guy should return a bool, and it's going to be send sync protocol server is supported protocol. And from that, we want the supported field in the response. Easy as that. Okay, and for the start download with an URL. Protocol server, start download, URL. Download ID. And finally, for the stop download, turns and sync protocol server stop download, download ID, success. Okay. I think this is our entire API class for Lib Protocol right now. So how do we use this? We'll make a little test program, I guess. Put something in user land, call it P. We'll make sure that user land, we want user land to build with Lib Protocol. And let's see if we can make sure that Lib Protocol builds. It didn't. Okay, some stuff to fix, no doubt. Let's just write out a little P program first of all. Core, C event loop. Maybe we don't even need those. Okay, stdio. So here we are going to, first things first, let's make an event loop. And then let's make a Lib Protocol client. Protocol client, and we'll say protocol client handshake. I think this should be generated for you, but right now it's not. Let's just make sure that the server and the client, they know things about each other that we depend on for functionality. But now we should be free to send a supported protocol, for instance. Cool. Let's see. Printf supports HTTP. And then we can also check if we support FTP. And hopefully that will say no, it does not. And then after that we can just quit. Or we could even just do it like that. We just have to have an event loop, even though we never actually enter it, because these are all synchronous. Let's see if that program was okay. Okay, well, we have so many things to fix now. So let's see, what was the problem with building protocol server? I guess protocol server doesn't even have a main. So let's see what audio server main looks like. Very simple. What the heck is an AS event loop? Feels like we can just have this object defined here. So we don't need a mixer. AS event loop. That, and what the heck is happening in AS event loop CPP? It's one chunky funk. So we'll just do it that way. Okay, and then we need IPC server. No, lib core, core IPC server. And we're also going to need PS client connection. Should listen in PS portal. And when we are ready to accept, we are going to accept, but we'll say protocol server accept failed if it fails. This feels like a really arbitrary thing to have in a separate class when it could also just be in main. And the server could be like that, and the event loop could be like that. C local server, just call it server. What is a C local server? Oh, it's a C object. Oh crap. Okay. Well, then it definitely needs to be a. It's a C object. Okay, and then goodbye to PS event loop, because I had a feeling that class was superfluous. Superfluous. Okay, that's pretty cool. And it's a nice little program. What else do we need? Okay, so we have this big ass build failure. This is probably in the generated code. Stream arrow protocol. So protocol server endpoint. Line 148. We cannot put something into a string. Oh, we don't know how to extract a string from a buffer string. So we haven't had any strings before in IPC protocol definitions, so we're going to have to add support for that in the IPC compiler. So that would be, where do we encode messages? Search for encode. Because if we look at the generated code, actually, then this is the is supported protocol message, inherits from iMessage. And here is how these messages are decoded. You can see that we have trouble here. And here is how they are encoded. Here we do not have trouble. It allows us to stream a string into it. I guess buffer stream tolerates string. Presumably it gets implicitly converted to a string view, and then the bytes are just copied into it. But that's not good enough for us, because we need to encode how long the string is so that we know how many bytes to decode. So here we want to tweak the encoding a bit. So when we encode a string, let's say if parameter type is string, then else we do the old thing. So for strings, we're going to output code that puts the string length first, and then followed by the string characters. Or I guess we can just send it like that, actually. Yeah, so the length followed by the characters. Because then when we decode, where's decode? Oh, I guess it's this. Decode for each parameter. Then we're streaming into a variable here. So we're going to do something like if parameter type is string, then do the string thing, otherwise do the old thing. Okay, so here comes the string length. Debug. Maybe we'll make a temporary right up here, actually. Or, no, we don't have to do it that way. We can do it this way. Say int, parameter name length is 0. And then we will stream into that. So stream into parameter name length. And then we need to read as many bytes. So does buffer stream have a way to read a number of bytes? There's only stream operator into a U8. We can use that. So we can say that what the heck is the API for that? String impl create uninitialized. Auto parameter name impl and string impl create uninitialized parameter name underscore length comma the name for the character buffer parameter name buffer. Okay, then we'll also need to store one of those, so put that right next to this guy. Like that. Then this buffer will be where we read the characters into. So for int I 0, I less than parameter name length plus I. Code generation in C++ is fun. It looks really weird, but it's not bad at all. And then finally here we want to just read from the stream into the parameter name buffer at index I, and that's it. So how did this turn out now? Audio, no, protocol server endpoint. Wait, this doesn't look the way I expected it to. Oh, this is the size T. We don't know about size T. Protocol server. Wait, what? Protocol is a string. Why am I not recording? Oh, I know what it is. I have to rebuild the IPC compiler. Protocol server. Here we go. Okay, so what did we do? Non-const al value. This was not good enough. String impl create uninitialized. Oh, it's a char star, and I made it a const char star. That's stupid. All right. and then we don't want to do this. So let's see, not const char star, and then not stream into parameter name, obviously. Okay, now this generated code looks pretty good. Of course, we still have to store the that string somewhere. So got a little carried away there. The parameter name is going to be a string is equal impl. I forgot the semicolon. If I had it, it still wouldn't work. What is string protocol? I can't assign. Can you do this? What about that? That would be okay. All right, let's do it that way. Do not save. So we'll start and semicolon it, and then please. Just let me do the thing. Okay, now this is looking reasonable. So why don't we build now? What seems to be the problem? Cannot bind. Oh, it's total size. Oh, I guess it doesn't like the U64s, maybe? Yeah, it doesn't like those. Okay, let's skip over that part because I don't want to implement 64-bit values in the IPC stuff right now. So let's just go with U32 for everything. You'll notice that I have made a custom QCreator syntax highlighting for my IPC language, by the way. Just because. Okay, and protocol server IPC. We didn't have any 64 there. Okay, now we're starting to get down to business. No declaration matches this. Did progress download. PS client connection. Did progress download. Oh, right. So it's my bad. Oh, wait. We could get those from the download. So that was okay that they didn't have those. And why are you abstract? Can I learn more? No? I don't know what I'm forgetting to implement, but unimplemented pure virtual at 396. Oh, it's the greet thing, right? Right. And what do we do without an audio server? I don't recall. Okay, so we're just going to copy this. for the PS client connection. Okay. Download CPP. We have some red here because we are passing too many arguments to did progress download. Or wait, are we? Oh, I guess we are, yeah, because we're supposed to just update our total size with these values. Okay, and then this looks like a missing header somewhere. In HTTP protocol, we need core HTTP job. And in HTTP download, we need to be passing the client to the base class here. So download client. And then we need to fix the constructor, so he takes the client. PS client connection, right. Okay, start download. We need the client here, so when you call start download, who calls that? I guess nobody calls it yet. We didn't set that up yet, so we have an API for calling it, which just sends this message, but we're not actually handling that yet. So that makes this easy. That just means that we just take the client here. So here, I think that's good. Now we're going to want to be able to instantiate this thing. So I guess we'll have an HTTP protocol. And maybe protocol should have a protected constructor so that you don't try to instantiate it just like that. Protocol, CPP, protocol server. Just like that. And actually, let's put the destructor here as well. Nice and out of line. All right. And maybe protocol should have some convenient thing like a virtual string name, so that you can reply with the name of the protocol. Seems nice enough if you want to enumerate them or something. It's an abstract class, right? Because we still don't have the name, but don't you worry. Override. There we go. Wow, look at that. Just built. Except the linking part. But that's easy to fix. Just need to link against libipc. Undefined reference to puff. What the heck? Oh shit. HTTP this libcore stuff that uses HTTP, it pulls in Puff, which is a zlib, standalone zlib implementation that comes from libdraw. At the moment, we should probably move that to libcore, but for now, we'll just pull in libdraw as well, and then we built. Okay, let's see if Lib Protocol would build. Yes, it does. And would userland build? Can't find Lib Protocol. So we have to update the common makefile and add a new library. Don't do that every day. Oh crap, we need libipc in the userland. The userland is starting to pull in everything, which is not great, because it makes things huge. But yeah, it is what it is. So let's do a full build, see where we're at, see if we can run this puppy. I feel like I've been programming for quite some time. So we didn't actually implement anything that handles incoming requests on the server side. Wait, no, PS client connection. So we just have those dummies. So this is not really how it's supposed to work. Let's see. So when we get the start download, then let's say we do protocol server main. This is where we'll instantiate the HTTP protocol. And then it should be registered with a list that we'll keep in the protocol thingy. So here we'll have some API like static protocol, find by name, something like that. And then in here, we'll make a friendly thing, like static hash map. All protocols. Hash map of what? Hash map of string to protocol. And okay. All protocols. Set this. But we can't call name here. That's pure virtual. Can we call it here? No, we can't. It's C++ stuff. All right. Well, we can at least remove it by value. So this will be ugly, but we'll. You know what? We're never going to be here anyway. We're not going to unregister protocols at runtime, so I'm just going to assert that we don't get there. And then we'll do it this way instead. This const string name, and then name won't be virtual anymore. It will just be like this, and then we'll stash that away here in a string. All right. Doesn't this simplify things? Name, and then that our friend HTTP protocol can just call protocol, which And we can get rid of that. And boom. All right. So now the protocol constructor will add it to this map. And then we'll have a friendly helper for this. Like, what did we call it? Protocol find by name. Return all protocols. Get name, value, or null putter. Okay, cool. And I'm just going to be a little bit cautious here and see auto. I just want to make sure that we don't invoke that destructor and start asserting. So just a little ugliness. We can even do it this way, actually. We don't need to do anything more than that, because leave me alone. Okay, cool. Now in PS client connection, let's see. So what we want to tell here now, instead of this, is protocol find by name message protocol to lowercase. We'll need to include protocol.h for this. It's pretty cool. So if we find it in the protocol map, then we will say that we support it. Okay, and then protocol find by name message URL dot. We need, wait, doesn't URL have a protocol thing? Oh, it's a string. Shit. All right, all right. URL from message URL. We'll assert that it's valid for now. And then here we can look it up by protocol. And then protocol auto download. We'll assert that we find a protocol as well, actually. Protocol start download with us, we are the client, and URL as the URL. Download ID. But now who keeps this thing alive? Start download. This thing has to be kept alive somehow, otherwise it's just gonna fall off the face of the earth here. So I guess we will just I guess when a download exists, we'll just put it into a map of downloads maybe. So we'll do the same thing here, hash map. I32 to download, non-null ref putter to download, all downloads, and return map, and here all downloads set mid this. All right. And then when we're told to stop a download, stop, then all downloads remove mid. This is how the download will get killed. Okay. So unless you stop a download, it's not going to be, unless you stop it or it finishes. Yeah, that's how we'll clean it up, when it finishes. So here we'll say all downloads remove mid. Yeah, that seems reasonable. Right, stop. So in PS client connection, we had that stop API. Now we know what to do with that. So let's see, auto download, find by ID, message, download ID. If not, we'll assert that we have such a download. Or I guess if we don't have such a download, then we'll respond full success false. If we do have the download, then download stop. And then download needs a find by ID helper. Which can just look in this map. So return all downloads, get id value or node putter. Okay, so first thing that we should have now is just, oh shit, where is that? Download CPP 15. I can't give you a null putter because, because it's a non-null ref putter map. I don't want to deal with you right now, so I'm just going to demote you to a ref putter map. Because there's a little bit of trickiness when you're using non-null ref putter as the value type of the hash map. It needs to be a little bit smarter about that, because otherwise get gets confused. But it's total minutia. So now we should be able to determine whether these protocols are supported or not. So here we go. Supports HTTP, yes. FTP, no. Pretty good for a first run. And then we crash in main. And the C object destructor in main. All right, all right. And PCPP, I guess. Is this a C object? Yes, it is a C object. Okay, I can't just be going around like this. Gotta be making it like this instead. Construct. Can't be going around making making C objects on the stack. It's not super supported. I'm out of T, but we're also making really good progress, so maybe that's okay. All right, P. It's looking good. So I'm thinking we could download something. Like this is IPFI service. It just gives you your IP. They have some really simple thing that you can call. I mean, like you can get it. I need something really simple. Is it ap.ipfi.org? Yeah. If we do this, it should give us the IP address. Or we could even use my local machine, actually. I don't know why I try to complicate things. Let's use my local machine. Okay, so then we'll say 32 download ID is protocol client. Start download. http:// my local host. And let's see, printf started download with ID. Download ID. All right. And then what? I guess now we're going to need to go in the event loop. Because we can't just wait here forever. So we want to be looking at those notifications. So before we start the download, we'll say protocol client on download finish. full success. And then here we can say printf download d finished success u. And I guess there's nothing left to do here except quit the event loop. We're going to need to capture that. And we can also listen for the progress thing, even though we not actually creating those progress things yet, but we can still put them here. Total size. Download D progress. D out of D. Oh no, hold on. U out of U. Download id and downloaded size, total size. Cool beans. I have no idea if this is going to work, but we'll see. This will be very interesting. It started to download, and then what? It just dies. Why does it just die? Something crashed. Protocol server crashed. Oopsie doopsie. Unrecoverable page fault in the kernel of all places. Yeesh. On-socket connected send. Okay, so maybe that was a fluke. Maybe that was not a fluke. Protocol server is crashing in the kernel. What the heck? Let's run it on the command line and see if we can learn something. Seg violation. Okay, so what the frick? So we're even getting some headers back from the server actually, so something good is happening. But stuff just goes horribly wrong. What went wrong here? This one is exiting normally, but the protocol server is totally screwing up. Recently freed memory. Well. That's not super good, bro. Let's see, event loop. Is that normally how you do that? There's one more piece of code that does that. I don't see why you shouldn't be able to make a C event loop on the stack. One here. Yeah, we have them. Oops. Okay, so let's just start in vanilla mode, and what's happening? Let's just look at the crash then. Send outgoing packets. It's messing up. We have a BBBBBB. And BBBBBB is kmalloc speak for a sanitized kmalloc allocation, which means that this was allocated but never written to. Ooh. Okay, so in send outgoing packets, it would appear that we're doing something with a piece of memory that is kmalloced but not initialized. Let's see, obj dump. Go away, Firefox. I wonder what's at this address. Byte buffer size. Oh, this is a read. We're calling size on a byte buffer that is uninitialized memory. So send outgoing packets. We are indeed calling byte buffer size. Right, where are we? Right after send IPv4 in send outgoing packets. Okay. What the heck is going on? Send outgoing packets. Which one of you guys is calling size? Right here, I guess. Send IPv4. Or this was after the call to send IPv4. It's right here at the end. So I guess it's packet.buffer.size. So maybe something happens with the packet here. Could the packet go away? What is packet? Packet is something in this list. An outgoing packet, not act. I suppose it's possible that somebody acts it in the meantime, and they would remove it from the list. That doesn't seem very safe. This list is not locked in any way. We should probably be locking that list. And look at all these people modifying the list without locking it, iterating the list without locking it. Sheesh. Just make a lock. And not act lock. And we'll initialize it with something. TCP socket unact packets. Okay. Just if you're ever debugging locks, then you can see what the name of this specific lock is. And then wherever we use this guy, not act lock, we're just gonna lockify. So there, and then here, and here, and we are probably good. Maybe that was all there was to it. Sometimes I feel like, I don't know, there's a lockable template that you can use. You could like wrap this in a lockable, but I don't know, maybe that's the right thing to do. Okay, so now we made it all the way, and then we crashed protocol server anyway, because protocol server gets very confused when I guess maybe when someone hangs up on him, he gets very sad. Let's see. What happens if somebody hangs up on you? Create one of these, PS client connection, and then presumably we die. Say debug PS client connection die. So we'll find out if this is happening. Crash, crash, crash. So we're trying to call a recently freed address, or recently freed memory. So basically what this means is that when we call free, then we will overwrite all of freed memory with this byte pattern. So this means that we are jumping to a pointer that was read from some memory that was recently freed. That's not super good. So who is jumping there, though? That's what I want to know. It appears to be right here. So I guess this the event loop is calling some code that has to be in here somewhere, because the event loop, the way that it invokes the event handlers is that it fetches all of the queued up events, and then we iterate over a copy of the event list, and I guess we could enable debugging maybe, or yeah, we could just enable this piece of debugging right here, because that would just tell us the address of the receiver. We shouldn't even try to dereference this. Let's just do it this way. Receiver. So then it's just we're just going to print out the pointer to the event receiver of every event and the event type, because then maybe we can find out that it's an attempt to do this. Because here you can see that we are calling receiver dispatch event, and even before that we're trying to create a protection pointer to keep the receiver alive, but maybe the receiver is already dead. So, what happened in protocol server, bro? Protocol server. Sending event 5, but this is a valid pointer, but maybe this pointer has been freed here, though. What is event 5? 0, 1, 2, 3, 4, 5. Deferred invoke. All right, we're doing a deferred invoke. And then we're dead. Very sad. So somebody is being naughty and doing something bad. This is unpleasantly undebuggable like this. I wonder if we were to not scrub free, would it just keep going? Like if we allowed it to use after free, what would happen? There's a way to turn that off. libc no scrub free. So kill all protocol server. Export libc no scrub free. No, is 1, right? My bad. Okay, now we have protocol server, and if we just run p, it still dies. Well, we should at least get something other than eddd. Oh, we get a null instead. I wonder if that's actually more interesting. Null dereference. Where's the crash actually? No scrub. Okay, I'm a bit weirded out by this, so let me just start this up with free scrubbing turned off. Because scrubbing malloc and free is really good at flushing out bugs, making them happen, but then figuring out what the bugs are is a whole other story. I so wish that I had Valgrind. I should probably sit down and make a Valgrind port at some point. Alright, so what actually happens now? I have a null deref, which is curious. So we're exactly at this address. We can actually look at that specific address and see what's calling null. So dump DCN Intel protocol server. It's a jump. Really? Wait, what? Oh, that's this call right here, sorry. So there's a ref, and a dispatch, and a deref. So that's that protection pointer, C event loop. This guy right here. So I guess we're doing this one. It's a deferred invoke on a freed object. I think that would be it. So if we do this and we say suspect I bet you that this is the thing that we're doing. Okay, so then we can turn that off and only this, and we don't do that. And make all. Deferred invocations. So deferred invoke is like you can call on any C object. You can say, "Hey, call me back next time you're in the event loop," and just call this arbitrary function pointer, basically. So oh, printf. Damn it! I should have looked in the window. Debug printf comes here, but printf comes in the terminal. But because protocol server does not run in the terminal, then that output is lost because it's a standard out if that program doesn't go anywhere. Okay, so deferred invoke. Suspect. Is it possible that this thing is? I would have expected the suspect here to be null. But at the same time, if receiver were null, then it would have been clear here, and we would have skipped over this. So let's do it this way. I can print out the invoke key. How do we turn this thing into a void star? It's a function object. How do we get this thing out from this thing? I guess we can check if it's bool or not. That will tell us if it's set. Just cast it to bool. So these things are supposed to be using weak pointers. Queued events the receiver pointer is a weak pointer to AC objects, so it should become null. Okay. It should become null when it's deleted. This is the last thing that we see before we die. Deferred invoke with this receiver. And I wonder if we can also print out what the receiver name is at that point. I feel like I've seen this crash before and I just never took the time to look into it, so it's probably a good thing that we're running into it now. Alright, so what's the matter? The server is a CHTTP job. Now scrubbing is turned off, so if we turn that back on, true, then I wonder if it's gonna have a totally busted vtable pointer and just crash when we try to call class name on it. Which is what this will do, by the way. So passing a dereferenced C object like this to the debug stream will print out the name of the class. Okay, receiver, blah, 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 blah. Here. Aha. So the CHTTP job is actually deleted here, and it's freed memory, and we're calling something on it. Is that what we're learning? Receiver is a... Oh, wait. Are we still fine after this? We survived it. Because maybe I'm totally looking in the wrong place here. Maybe something happens inside of this deferred invocation. And I am just being silly. Oh, there are so many moving parts here. CHTTP job, we don't survive that call. Okay, so we know at least that we're going into that deferred invocation, and then we don't survive it. So CHTTP job, we'll do a bunch of deferred invokes. Deferred invoke. And in most of them, he'll just do did finish or did fail. So we could definitely log when those are happening, because if we turn on this debug logging, we'll get either a message for fail or finish. And then we can learn which one is happening and where's the death? The receiver is this type, and then did finish. So we're here, and this is printed. This does not assert. Then we call on finish true, and that puts us somewhere else, and then we call shut down, which will remove the socket child. The socket is a child of the job. How does that work? Okay. We get rid of the socket that we were using for the job. Okay, that's fine, but do we... I wonder how far we get here. And this stuff should end up in the protocol server here. Because we sent the thing to the little test program, right? He learned that he had finished. So we must have been sending this, and then we remove the download from this, the hash map. And is that not fine? Is somebody still using it at that point? HTTP download on finish has captured this. I mean, how do we want to do that? We could defer. I'm not exactly sure what is causing this to stir shit, but if we don't remove the download here, so we just let it linger, let's see if that fixes the crash, because then we know at least what to pick at. Alright, so we don't crash if we let the download stay alive. That means that the destruction of a download is causing trouble. Did finish. So is there something going on beyond this? When we did finish, then do we get any more? There was a deferred invocation on the job, but I assume that we're in that deferred invocation, right? So the job is still kept alive. It's just the download itself that's dead. Guess we can try to learn a bit more. Calling did finish. Returned from did finish. And let's see about download has the job, but download is gone, so job is gone. But I don't see why that should be causing us any trouble, unless we are now like... Is it not okay to destroy a Lambda while you're executing inside of it, maybe? I'm not sure, actually. We could certainly defer doing that. We could... I just want to find out. I suspect that we don't return from it, or if we do, then returning from this is not working right. So that's crashing. Calling did finish, return from did finish. Keyboard, calling shutdown. Okay, we're going all in with the printf debugging again. No regrets. It's funny, when I talked about printf debugging in the commute talk the other day, people have really strong feelings about this stuff. Fascinating. And I really like printf debugging, so it's all cool. Calling shutdown. So we make it all the way to shutdown, but then things go crazy bad. Okay, so okay. I legitimately don't know what to think here. So I guess we'll just go with the old trusty. Hit me with numbers. No, not like that. Like this. Because shutting down a job is all about disconnecting all the callbacks from the socket and destroying the socket, and then letting nature have its course. But it's not super well defined how that whole thing works. Calling shutdown. Then nothing? Wait, what? Wait. Calling shutdown. But in did finish, we probably destroyed this. Unfinish probably destroys the job, right? And then we keep doing stuff in the job. Well, aren't I silly? Okay, so let's protect ourselves. Non-null ref footer CNetwork job. Protector. And then even if we get killed in unfinish, someone will still be holding a ref on us, so we won't be deleted until we exit this function. So it works. Aha! Aha! Problem identified. So onFinish was making the network job be deleted. We don't want that to happen, so we'll protect ourselves. Note, we protect ourselves here since the onFinish callback may otherwise trigger deletion, destruction of job somehow. And I think we'll do the same in did fail, because they're also calling out to an arbitrary hook. Great. Now we can turn off that debugging. Isn't it nice when you figure out why something is going wrong? I love it. And where's that obnoxious stuff that I was doing? Here. Okay, well, I didn't know what the problem was, okay? Jeez. Jeez Louise. Okay, let's get rid of all of this paranoid mumbo-jumbo. HTTP job debug was actually already turned on. Alright, my bad. We have so much code. So shit, now I guess we should try to do something with the data that we downloaded. So we finished a download. I guess we can commit that libcore change. Libcore. Have CNetwork job protect itself. during onFinish on the onFinish callback, onFinish hook. Otherwise, the callee callback may trigger the destruction of the network job and make it difficult to continue execution correctly. Indeed. Did I spell that correctly? I felt like I had more F's in there, but I didn't. All right, all right. Okay, so we've finished, and what are we gonna do with all of the data? I guess we gotta hand it over to the client, really. What else are we supposed to do? So I think we're gonna give him a download finished. We'll give him a buffer ID. So, wait, where do we actually do this? Or maybe we can actually, let's commit what we have already. So, first up in the IPC compiler, support for string type, support for string parameters, messages, and the protocol server. Oh, no, wait, hold on. What was this kernel change here? We're protecting the unact packets thing with a lock. IPv4 protect the list of unact TCP packets with a lock. Otherwise, things get racy and crashy. Okay, and then let's do the protocol server stuff, and I guess all of these, everyone's gonna have to come along, not you, or maybe you. Oh yeah, that's a big, beefy change. So, protocol server plus Lib Protocol. Introduce a server for handling download. Protocol dispatch adds protocol server, a protocol agnostic, or no, it's not protocol agnostic, hold on. Protocol server, a server that handles network fetch network requests on behalf of its clients. The first protocol implemented is HTTP. The idea here is to use a plug-in architecture where any number of protocols can be added and implemented without having to mess around with with each client program that wants to use the protocol. A simple client API is provided via Lib Protocol client. Okay. That's pretty cool. And maybe we should call that P program something else. But P is also a cool name, but it's like, it's a little on the short side. So maybe P will be called Protocol Server Test. Lib Protocol Pro, that's kind of cool. Is Pro something? Not really. Pro. Okay, we can call it Pro. I can live with that. Meta. Commit pro. Add a little userland utility for interfacing protocol server. Well, really, it's testing protocol server at the moment. Okay. Now, we want to get the payload from the download here, like all of the bytes, right? And that's not even to mention stuff like HTTP headers and whatever. Like, we're going to need to be able to pass all that stuff. But I don't have infinity time to work on this right now, but let's do the payload. So did finish success. Oh, we should probably return from. Did I add a bunch of paranoid stuff in this commit that I didn't mean to? Debug. I guess maybe it was only that one. NPS client connection die. Didn't mean to leave that in. All right. Amend. No. Oh shit. I didn't mean to amend. I meant to git commit -a. Go away, lock. Delete full git rebase. And just squash that puppy into the previous one, removing the foo. Itchy face. All right, and then finally, wait, I'm so far away from, I'm not too far away from origin master. I thought I was messing up my Git history somehow, but we're good. So let's see. Job on finish. Let me call it did finish. And we should probably pass it response thingy. So did finish. We'll call it set payload. Maybe. Job response C HTTP response payload. All right, and that's going to be a download thing. So here we'll have like set payload. Buffer payload. It's not gonna fire anything away yet. We'll just cache this away, I think. So payload payload is payload. We're not going to send it yet. We'll send it here. Did finish download. And then we'll have a way to extract the payload here. So we'll do like byte buffer payload const return payload. And then in did finish download, we can check if download, if success, and download payload is not null. Buffer ID, let's say. Then create shared buffer. And it's going to be how big? It's going to be download, payload, size. Or maybe we can use the libc shared buffer API actually. Create with size. Download, payload, size. Why am I editing so weirdly? And then buffer data. Then copy buffer data, download payload size. And why can't I do that? Because I have to do data here. And then also we have to share this. Share with. How do we client connection? We need to know the process ID of the client. Client PID. That's what that greet thing is all about. Because this allows us to already know the client PID. Although we should maybe have some other way of getting the PID of the other side of local socket, like maybe some IOCUDL or something like that. Maybe a get sock opt thing. I don't know what other systems do. Basically, doing this means that this PID will be able to map this shared buffer into his address space, and then we'll do seal, which makes it read-only memory from this point. So. In fact, we could do this before we share with. That's what we should be doing. So we create the buffer, populate it, and then we seal it, which means that it's read-only now. And then we share it with this other process, but it can never be modified. There's no unseal. And then in the message, we'll say if buffer. We'll include the buffer ID, otherwise -1. And protocol client IPC will have the int shared buffer ID, not int, I32. Okay. Make all. And I'm sure I'm definitely forgetting something, but we'll figure out what it is. Is it this thing? Where do we get the download finished message? Oh, right. We get it here, the shared buffer ID. So we have to add it to this thing. Okay, so now when the download finishes, there's going to be a shared buffer for us to pick up in pro.cpp. Shared buffer ID. Let's just print it out, see if we get one. Shared buffer id. It's a bizarre number. That's the same number again. I don't like that. Just that number, is that number something hexadecimally that I can't tell? Oh, base 16, 3, 4, 7, 0, 1, 3, 9, 2. It's a number. Why are we getting that number, dude? Download the success your shared buffer id. What the frick? What the frick? Shared buffer ID. Download finished. Where did we send this? PS client connection. Download finished. Let's look at someone else who does this. Or wait, hold on. Let's say it here instead. So buffer is this did finish download. Buffer is buffer better. I wonder how we're messing this up. This image is mounted. That's my bad, I guess. Or maybe we should teach the scripts how to unmount the test file system if it's already mounted. Shared buffer ID 9. Well, see, that's a much more reasonable number. Maybe I just had some silly problem before. 10. Yeah, that's what I would expect to happen. They would increment. Alright, maybe I just had, I guess maybe I just had a shitty rebuild. Probably I did, actually. So let's not think too much about that, but instead we'll just move forward with the pro program. So if we do have success, if success, we'll assert that shared buffer ID is not -1. And now we're going to map it into our memory here. So we'll grab libc shared buffer. We'll say shared buffer, create from shared buffer ID, shared buffer ID. Booyah. And that should do the trick. I guess we would want to know how big it is. When you create a shared buffer, it's always in multiples of the system page size. So really this API should include how big the download was. Total size. Let's include that. So let's say U32, total size. And that'll have to be here. Total size. We're just working our way backwards here. And where we send the message, it's download total size. Oh no, we can actually use the payload size. So total size. Maybe when we 32. Wait, no, what's wrong with this? Oh, right, yeah, I didn't update the generated code still isn't updated, so it's okay. but when we call set payload, that means that we now have the canonical total size. So we should just say total size is payload size. Oops. I need to go through a lot of code and change a bunch of ints to size t. It's a bit annoying. Download finish. In client CPP, I can't be calling it this way because wait, why not? Int bool int. Maybe I just forgot to save something. I think that was probably it. Pro CPP, we are not using total size, right? So payload bytes is byte buffer wrap shared buffer data with the total size. And finally, we can just write that shit to std out. Payload bytes data, payload bytes size. All right. Let me see that sweet Apache 2 default page HTML on my standard out. No! Get shared buffer, invalid argument. Dang it. Is it that the shared buffer is... Do we have to keep the shared buffer alive? PS client connection. We send this to the client. But then the client, this will go out of scope. So what if we just leak it? We'll just leak a little bit here. Buffer, leak graph. Just see if that fixes it. That's not going to compile, maybe. No. Because of no discard. But basically, the shared buffer, it goes out of scope here before the client can map it into his address space. And unlike regular Unix, we actually take it away if that happens. So that's what it should be like. Freaking awesome. But we need to fix this one last thing, which is the leaky thing. So we're going to have to hold on to this shared buffer until the client tells us that it's okay. So how do we want to do that? It would be nice if the kernel had a mechanism where you could like pass ownership of a shared buffer through IPC. We could definitely build something like that, but right now I just want to hack something to finish this for the day. So I think we are going to remember all of our shared buffers here. So we'll just have a hash table or hash map, say, of download ID to shared buffer. And then we'll have a message that the client can send that will forget a download. Or disown shared buffer. We'll call it disown shared buffer. And this will be our little hack for now. And then we need to store them like that. Yeah, right. Shared buffer. So in this API here, disown shared buffer. Fix me. It would be nice if the kernel provided a way to avoid this crap. Avoid this. Don't have to exaggerate how bad things are. It just makes them seem worse than they are. Disown shared buffer did. And I guess we can just say nothing in response to that, because there's nothing to say. Okay. And in the handler for that, disown shared buffer message. We'll do m shared buffers remove message shared buffer id. Okay, now it's up to the client to do this. So the client will actually do this after we invoke on download finish. We'll have the server disown the shared buffer. Yeah. Send sync protocol server disown shared buffer. PS client connection. What? Oh shit, we have to return something. Make protocol server disown shared buffer response. It's pretty fun to do IPC programming. I mean, this system, the IPC system here is not perfect, but it is pretty nice. And why did that not work? Dang it. Oh shit, because I never added to the set buffer shared buffer ID buffer. I have to actually add it to that map, otherwise it's not going to be kept alive. That was the whole point of having the shared buffers map. And of course, note that this here is a member of the client connection object. So if the client disconnects, it will also clean up these share buffers that we're holding onto on his behalf. So if the client crashes or whatever, we don't leak the buffers. They actually do get disowned. Ooh. Freaking awesome. Okay, so let's commit this. Protocol server. Send the download payload to clients as a shared buffer. Download finished message from the server now includes a shared buffer buffer ID that can be mapped into the client program. To avoid the handoff, prematurely destroying the buffer. Server will hang on to it until the client lets it know that they're all good. That's what the protocol server disown shared buffer message is about. In the future, it would be nice if the kernel had a mechanism where to allow passing ownership of a shared buffer along with an IPC message in somehow. Cool. Maybe maybe we can take a URL on the command line here instead also, because that just makes the tool a little bit nicer. Let's see. If RC is not 2, printf usage Perl. Return 1. Dang it. Or maybe just return 0. String Perl. It's RHV1. Perl string. If Perl is valid, we'll say that it's not a valid URL. That's what I'm thinking. And we don't need to be calling those things anymore, but then we can do printf, or fprintf for that matter. Stir is not a valid URL. Sorry. Perl string dot characters return 1. Alright, and then down here we'll just pass to string. Alright, now we have a little tool that we could maybe, we could actually put this kind of stuff on the debugger instead, and then you would get nothing but the payload on standard out. That'd be nice, wouldn't it? ap5.org. Cool. All right. That's pretty awesome. And then, of course, you can go here and find the debug output, although maybe we should use this one instead. I don't know. Or no, I'm lazy. I'm not going to do that now. Commit pro. Take the URL. Allow. Take the URL to download as a command line argument. Also, don't print anything other than the download payload to stdout. Okay, now we have a very simple HTTP. Alright, this gives us a very simple HTTP downloader. Download. Cool. Okay, so I think that's going to be it for today's video. Went on for a while here, but I think this is pretty cool. So let's get serenityos.org. Look at that shit. Yeah, we now have a protocol server that can handle downloads on our behalf, which will allow us to do awesome stuff like implement any kind of protocols, and then we'll be able to use them from every program instead of having to worry about that in every program that wants to do networking. And this will also make it easier to do something like HTTPS, because we'll be able to build like a little plugin for HTTPS that can add itself to this thing instead of having to. I'm not going to have the base system depend on some external SSL library. So, but this, if we can make a plugin system here that would allow you to make an SSL provider or something like that, a HTTPS provider that's based on a port, that would be optional. So I'm looking forward to that. Anyway, yeah, that's going to be it for today, definitely. So I hope you saw something interesting here. And my computer is freezing up. Dang it. So I hope you saw something interesting indeed. And I will see you next time. Bye.